Hello friends, welcome back to channel. Today we will discuss about Logical Volume Manager LVM in Linux. So what is LVM? LVM stands for Logical Volume Manager. It is a system for managing and organizing disk storage on Linux-based operating system. LVM allows for the creation and management of a logical volume which can be treated as a virtual disk that can span multiple physical storage devices. Means your storage will be on multiple physical disks. This allows for more flexibilities in managing storage and making it easier to perform tasks such as resizing, moving partition. Additionally, LVM provides features such as snapshot, which allow to create a point-in-time copies of a volume, and mirroring, which can be used for the data redundancy and recovery. So there was some limitation in a traditional disk partition method. That's why they have introduced the LVM. So what are those limitations? One of the main reasons of using LVM was the need for more flexibility in managing disk storage. Traditionally, disk partition methods such as a master boot record and the GUID has fixed number of partition and fixed amount of the disk space allocation to the each partition. Like we have already discussed, we can create only 4 partitions in a traditional method. This can make it difficult to add and remove storage. Resizing is a very typical job in a traditional method. Now, reason of using LVM introduction: the need for a better data management. Traditional disk partition method do not provide features such as snapshot mirroring, which can be used for data redundancy and disaster recovery. LVM also provide a more powerful and flexible way to manage disk storage on a Linux-based system. It allows you to create managed logical disk, which can span on multiple physical storage devices, and provide features such as snapshot mirroring for redundancy and disaster recovery. LVM allows for dynamic allocation of resources, which means it is possible to allocate disk space on a different volume or systems as required rather than being fixed to the time of partition. So that means in traditional we are fixed while creating a partition, but in LVM we are having free space. After creating a partition also we can do some changes without removing data. Overall, LVM was introduced as a way to address the limitation of traditional disk partition method and provide a more powerful and flexible way to manage disk storage of a Linux-based system. Benefit of using LVM: LVM provide a number of benefits over traditional disk partition method. Some of the key advantages of using LVM include flexibilities. LVM allow you to create and manage logical volume which can span multiple physical storage devices. This make it easier to address or remove. This make it easy to add or remove storage and to resize and move partition as needed. Data management: LVM provide features such as snapshot, which can be used to create point-in-time copies of volume, and mirroring, which can be used for data redundancy. Performance: LVM can use to stripe data across multiple physical devices, which can improve performance by spreading data across multiple disks. Resource allocation: benefit of using LVM: resource allocation. With LVM, disk space can be allocated to different volume or system as required, rather than being fixed at the time of partition. So after creating a partition also we can make some changes in the size and the disk allocation. Versioning: LVM allow you to add new version of operating system or software while keeping the previous version. Overall, LVM provide a more powerful and flexible way to manage disk storage on Linux-based system, which can make it easier to manage and maintain your storage infrastructure. So in traditional method, what we are doing, we are attaching a disk to a OS. Then once we bring up the OS, we will be able to see using lsblk, then fdisk and /dev sda b c, whatever disk we name we are having, we will create a partition, then we'll format it using mkfs and we'll mount it. So attach to a disk, create partition, format and mount. But in LVM, what we are doing, we are attaching a disk to OS, lsblk will say, then we'll take that disk under pv, then we'll create a vg, then we'll create on lv, then format and then mount. So they are bit 2 or 3 steps more, but those are okay because that will help you to achieve few things in the future. So first we'll create a PV, physical volume, then VG, volume group, then LV, logical volume. So architecture is like that. First we'll create a PV, over a PV we will create a VG, over a VG we'll create a LV, and then we will be able to format. First we will discuss what is the traditional method of creating a file system. Let's assume we are having disk Y 2, and 3. Okay, all three are for size of 10 GB. 10 GB. This is also size of 10 GB. This you can say size of 15 GB. Okay. Now this is the SDA, SDB, SDC. These are the 3 disks attached to my system. If I want to create a partition of this, so what way I can do? I can create maximum 4 partition. That is the one limitation. So now I am having this SDA, B, and C, and I want a partition that should have size of 25 GB. So I will not able to create a partition with size of 25 GB because all disks are 10, 10, and 15. If I want a partition of 25 GB, I have to create one more disk and attach to a system that should size around 25 GB. That is also one limitation. So if I create a file system on SDA like here, so what I will be able to do, have this format, and I am able to create a partition. Maximum size should be 10 GB, not more than that. Okay, same goes with this. In SDB also I will be able to create a partition size of 10 GB only, not more than that, or less than 10 GB. So in SDC also I will create a partition of 15 GB or like 5 GB and 10 GB, 2 different partition I can create. So that's how I can do. But the complete size of all the 3 or 2 partitions should be part of like SDA1 is like this one. So let me give a name to this SDA1, like I have taken SDB1, and this thing SDC1 and SDC2. Okay, so those are the limitation. I can create a maximum size of 10 GB. Even though I am having a 35 GB, then also I will not able to create a size of 25 GB partition because I cannot attach this thing. So that was the limitation. Now let me clear my screen. Now let's assume what LVM is giving. Like we are having 3 disks, 10, 10, 15. Okay, 10 GB, 10 GB, and this one is 25. So what we'll do, we'll take under PV. So we'll create a pool. So LVM will not accept the raw disk. So it's required that needs to be under PV. So this should be PV1, like I have given a name, PV2, PV3. So we have taken this 3 disks under a PV. Okay, and PV means physical volume. Then we create a logical volume group. This will say region. And we have attached all the disks PV1, P2, V2, PV3 to this VG. So size of the VG will be 10, 10, 20 and 25. Total will be 45 GB. Now we are having a VG of 45 GB. If I want to create a complete partition, I can create, or I can create a chunk of this partition like different size. Like I can give 5 GB to this and 10 GB to this, 7 GB to this, 20 GB to this, 10, 20, 30, 35, 42. Still 3 GB is remaining. That is still visible in a VG. Further, if I want to extend, like I'm using 20 GB, I want 1 more GB in this. So I can extend using the LVM command. So this small chunk will be LV. Okay. So LVM is having 3 layers. One single disk, volume group here, and last is this. Let me explain you. First, let me fill the color in this. That will be easy to understand. Okay. These are the physical disks. Physical volume, then volume group, then logical volume, and last mount point. So this is the complete process. First, whatever physical disk attached to a system using LSBLK will see, and using fdisk-l also we will able to see. Then we will bring those into physical volume. So pv create command we will run. So it will be part of physical volume. Then we'll create a volume group of those PV. The volume group means a pool of PV will create. That is a volume group. From volume group we'll cut small size according to our need and use the logical volume. And remaining free size will be available with the volume group. In future, whenever it required a free like to extend any file system, we can consume that space. If that space is also got consumed and still like we have consumed all the 45 GB and still we want some more space to save some data, we'll attach new disk. We'll bring that disk in a PV. We can extend a VG and then we can extend the LV or create a new partition using that. And further, after getting logical volume, we can mount it to a OS. So that's the complete process of creating physical volume, volume group, logical volume, and mount point. Rest we'll see in upcoming videos when we'll create and get set on. Thanks for watching Daily Study. We'll cover LVM in more coming videos. There are much more to discuss and show you. See you in the next video. Till then, keep practicing. Goodbye.